One of the most important concerns of a civil engineer in designing a structure is its safety. The engineers must acquire accurate design loads to create a safe and stable building. This is especially true for the foundations. Engineers apply higher safety factors for the foundations for the simple reason that unlike the superstructure, it is almost impossible to predict their failure and repair them. To avoid these, subsoil exploration is needed to know the actual conditions, geotechnical parameters, and allowable bearing capacity in a construction site. In an urban area like Metro Manila, being the center of economic and political power in the country, construction occurs often. But sad to say, not all of these projects are given the necessary budget for subsoil exploration. This would leave the foundation designers no other choice but to come up with the geotechnical parameters out of their own imagination, which would of course jeopardize the safety of the structure and its occupants. This study would help prevent just that. We proudly present the ultimate guide for foundation design engineers in estimating the allowable bearing capacity in Metro Manila. Shallow Foundation Design Reference for Metro Manila. After collecting vast amounts of borehole logs all throughout Metro Manila, calculating the allowable bearing capacities using the various geotechnical theories, and pinpointing the borehole locations on the map of Metro Manila, the researchers have made maps that can provide an estimation of the allowable bearing capacity for shallow foundations to a depth of 1 to 5 meters within the National Capital Region. Collection of borehole data was done in every city and municipality inside the NCR. Once the data were organized per city, the geotechnical parameters such as the groundwater level, soil type based on the USCS classification, and raw SPT data was extracted and utilized to estimate the bearing capacity using theories by Terzaghi, Vasic, and other researchers. The calculated ultimate bearing capacity was converted into allowable bearing capacity with a factor safety of 3. After calculation of the allowable bearing capacity, the data was plotted onto a map of the whole Metro Manila using the latitude and longitude of their corresponding locations. With this information, contouring of the bearing capacities was possible using inverse distance of a power method. In order for the researchers to make a contour map of the bearing capacity, the required data must be tabulated such that the contouring program will understand the tabulated data. Select the latitude and longitude data as well as the allowable bearing capacity of a depth being considered for the contouring program to generate a contour map of the desired depth. Once the map has been generated, the user can alter its properties and insert legends to make the map more suitable according to the user's preference. Thus, the allowable bearing capacity contour maps were made. What are the contents of an allowable bearing capacity contour map? First, the map itself. The contour map is bounded by the regions of Metro Manila, thus having a latitude and longitude scale of the boundaries of NCR at its sides. Second, there is a color scale located at the right side of the map. This is used to estimate the allowable bearing capacity of a location within the boundaries of the map. These correspond to the bearing capacity value indicated at the site. Find the location that needs to be checked for allowable bearing capacity by pinpointing its latitude and longitude. Then compare the color of the point with the color scale provided in the site. Take note that all 16 cities and 1 municipality that are within the Metro Manila have allowable bearing capacity contour maps, as well as Metro Manila as a whole. If the user wants a more specific city, he can opt to choose a map that corresponds to the city he wants to see. If the user wants a bigger view, he can use the whole Metro Manila as his reference. With this, virtually anyone can estimate the allowable bearing capacity for shallow foundations of Metro Manila for a depth of 1 to 5 meters. Here is a short demonstration of the borehole database using the GIS program. First, we have multiple layers that can be turned on and off whenever they are needed. The grid layer basically just shows a grid for reference. The terzaghi layer shows the location of all of the borehole as points. The administrative map and political map layers both show the boundaries of the cities in Metro Manila. The map layer shows the base map of the GIS. Then, we can search for any location in the map through their coordinates by inputting them in the coordinate bar at the bottom. The coordinates must be in decimal form for this to work. The blue dots in the maps are the plotted borehole locations. Clicking on them will show the name, coordinate, elevation, and bearing capacities of the borehole location. Another feature is the database itself. All the data of the borehole points can be seen in this table. Additionally, the database also has a simple search function. Matching results are the entries that are highlighted in blue. Aside from these, we can also zoom to the location of any selected entry in the database simply by selecting the entry and clicking the magnifying glass icon. Selected borehole locations are then highlighted in yellow. Apart from the simple search, an advanced search function is also available. Conditions or queries can be used to perform the search. For example, one can search for the borehole locations where the bearing capacity in the first layer is less than 300 kPa. The number of matching results can also be seen. Same as before, the results of the search are highlighted in blue in the database and in yellow in the map. Lastly, the queries made by the users in the advanced search can be saved. These can also be loaded at a later time when needed.